Now, have you visited our Space Nuts website in recent times? You should. I mean, not only can you listen to the Space Nuts podcast and all our back episodes there, you can go up the top and there's a whole string of links. Astronomy Daily, which constantly updates people on space, astronomy and science news, sometimes a little bit out of left field, but a lot of the mainstream stuff gets a mention there. There's also the AMA tab where you can upload your audio questions or your text questions. There's the Space Nuts shop, of course, where you can look at all the goods that we offer for you, from T-shirts to caps to cups to silly little books and so on. And a bit of information about supporting Space Nuts in whatever form you desire, whether that's as a patron or as a one-off donation or through the shop. So just have a look at it, spacenutspodcast.com. That's our website, spacenutspodcast.com. Now, Fred, we are going to talk now about this unusual phenomenon which has been affectionately referred to as space blobs. Now, these space blobs appear to be sort of galactic in nature. Some kind, I believe they're quite large, but they're more of a ghostly type of apparition than they are a galaxy as such. So they've been affectionately called space blobs. Do we know much about them?
No, not really. And they're a relatively new phenomenon. And in fact, their technical name is as entertaining as the blob name. They're called odd radio circles. And I actually know some of the researchers who've done this work quite well. And one in particular, Professor Ray Norris, who's an old friend of mine, odd radio circle is exactly the kind of thing that Ray would describe something as, and so I'm sure that's where the name came from. This is work.
I, on the other hand, am an odd radio presenter, so I can understand.
Yeah, they don't come much odder.
No.
So this work goes back a couple of years, actually. In fact, I think it was last year that the first reports came in from data collected the year before, and they come again from the observatory that I've mentioned already, the Australian Square Kilometre Array Pathfinder, an array of I think 13 or 14 metre dishes, maybe 12, can't remember, which are at a place called the Murchison Radio Astronomy Observatory in remote Western Australia, one of the most radio quiet places on the planet. Yeah. Until the mega constellations of satellites go past. That's another story. But the ASCAP, the Square Kilometre Array Pathfinder, has done some fantastic work. For example, in the fast radio burst science, they've contributed a lot to that. But this is another of their discoveries, and the group that are working on this, led by a scientist from Babel, who I know reasonably well, based at CSIRO and at Western Sydney University. Babel Korybalski, I didn't give you... Babel, I guess it is, because there's an umlaut there, of CSIRO, Western Sydney University, has led the group looking at these strange circles that have been found, the ORCs, or odd radio circles. So the story, the backstory is, I think 4 were found in their original survey for these things, but another one has now turned up. It's got a fabulous name, DESJ010224.33 minus 245039.5.
Yeah.
Which tells you exactly where in the sky it is, because those numbers are its coordinates on the sky. And that's what they are. They're circular structures at radio frequencies. You probably don't have to look too far to find an image of them. I'm actually looking at the Science Alert website, which has got a report on this. Astronomers detect another mysterious ghostly circle in
it looks like a topographical map.
Space. Yeah. Well, that's the radio intensities. radio astronomers tend to, certainly at low frequencies, they tend to show their images which look like contour maps, exactly as you've said, but this is overlaid with the same area of sky at different frequencies, probably optical and maybe even X-ray or something like that. And you can see that there is evidence that this thing has a circular structure. So one of the things that you can't just find out from these ORCs is without kind of taking other things into consideration. You can't get their distances. And that's, if I am remembering correctly, is because they're essentially, they're not emitting single frequencies. They're what you would call a continuum, a radio continuum observation, and that doesn't let you work out the redshift, which doesn't let you get the distance.
Right.
However, with this new one, the ESJ01, etc., what the team have found is an elliptical galaxy right in the middle of it. It's a radio galaxy, so it emits radio waves. That means it's probably got a black hole in the middle that's churning up stuff. But it's in the dead centre of this ORC. And that could be a coincidence, except that two of the other four of these objects, which were published last year, also have one of these elliptical radio galaxies right in the centre. And I think they've worked out that the odds of that being a chance alignment, a 1 in 200 or thereabouts. So it looks as though this is telling you something. And in fact, the first thing that you can do is say, okay, if this ORC, if this radio blob, this odd radio circle, is associated with that galaxy, then you've got its distance. Because the galaxy, you can actually measure its distance, and that, if the circle is associated with that, then you get the distance. And once you've got the distance, you can tell what size this thing is. So the new one that's been discovered, they get almost 1 million light years as its diameter. And that's big. When you think the distance between our galaxy and the Andromeda galaxy, our nearest large neighbour galaxy, is 2.5 million light years. If you imagine our galaxy with one of these circles around it, it would be halfway to the nearest galaxy. So it's the nearest big galaxy. So that's telling you something. What these scientists do is propose 3 possible emission mechanisms. One is, and I wonder if this might be the answer. The first one that they've thought of is if you're looking end on to what we call a radio lobe from one of these radio galaxies. And what I mean by that is that when you look at galaxies, these what we might call active galaxies, which are in fact the elliptical radio galaxies, they're bright in radio frequencies. Often they've got these 2 jets coming out of the centre, and that's stuff being emitted by the black hole. That stuff kind of hits what we call the intergalactic medium, the very rarefied plasma that surrounds galaxies. It hits that stuff and spreads out into a big bubble. So there are several of these radio galaxies. When you look at them, there's a blob of radio emission in the middle. There's these 2 jets coming in opposite directions out of the nucleus of the galaxy, and then a kind of bigger amorphous blob on the end of one of these jets, which is, as I said, where this material collides with the interstellar medium. The intergalactic medium. So if you imagine that we are looking end on at one of these radio lobes, maybe that is what we're seeing. It's one of the possibilities. And because they're end on, they look circular. The other 2 suggestions: one is a giant blast wave from the central galaxy, but they struggle to get the amount of energy that you'd need to form that blast wave. It suggests perhaps something like 2 supermassive black holes merging, which will be certainly a gigantic effect. And the other one is just simply an interaction between a radio galaxy and this intergalactic medium I've been talking about. But that's, you'd expect if a galaxy is moving through that medium and something's happening to cause radio emission from its surroundings, you'd expect it to be distorted. You wouldn't expect a perfect circle.
No.
So they sort of rule that one out. So, we know of 5 of these things now. They're odd radio circles, very odd, and people are struggling to explain them. So I think this is one of these things that you and I will probably talk about again down the track, Andrew.
And I guess, having found 5, it would be a fair assumption then that these are numerous.
Yeah, that's right. There's lots more of them. And, another line of research with this is to observe them at different frequencies, because that's always the thing that lets you piece together the jigsaw puzzle of what's happening.
Yeah.
Observe them in X-rays, visible light, infrared, anything you can get hold of.
Yeah, well, I love the name Odd Radio Circles. Space Blobs works for me too. Anything along those lines I'm happy with. But, lots to learn by the sound of it. You're listening to the Space Nuts podcast, or you might be watching us on YouTube. That's your bad luck. With Andrew Dunkley and Fred Watson.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.